So running along the shore is Einstein's dog chasing after the boat. So the boat is moving at 3/5 the speed of light. And what happens is the dog barks once, and then barks again, one second later, 5 meters down the coastline. So we can call these things two separate events. So we have event A, which is the first bark. From Newton's perspective, that happens right next to him and happens at time equal to 0. So event A happens at time 0 and at space 0. So these are the time and space coordinates of where the first bark happens. Event B, which is the second bark, happens 1 second later, 5 meters downstream. So you can ask the question, where do these two barks happen for Einstein? Well, to do that, we simply need to use the Lorentz transformation equations. So Lorentz transformation equations are T prime is gamma T minus dx over c squared, and x prime is gamma T minus, x minus dt. So for event A, where time is 0 and space is 0, t is 0 and x is 0, if I plug in 0, 0, 0, 0, I'm going to get 0, 0. So this is what Newton sees. Now let's write what Einstein sees. So if I plug in 0 for t and 0 for x, for both these things, then I'm going to get 0, 0 again for Einstein. What about for event B? Well, for event B, I'm going to plug in 1 second for time, and the velocity, which is 3/5 the speed of light. So 5/4 is gamma. Time is 1 second minus 3/5 times the speed of light times 5 meters divided by c squared. So that's equal to 5/4 times 1 second minus 3 meters over c, which is actually a very, 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 very small correction. This gamma factor here is the bigger correction, but that's the final answer for t prime. What about for x prime? Again, we have gamma of 5/4. The x coordinate is 5 meters minus the velocity, which is 3/5c, times time, which is 1 second. And that's our final answer. So these are the coordinates that Einstein sees these events happening. This is the x prime coordinate for Einstein, and this is the time coordinate for Einstein.